Ernst Leonard Lindelof, born 7th March 1870, died 4th June 1946, at the age of 76. Nationality Finnish. Alma mater University of Helsinki. PhD 1893. Known for Lindelof Hypothesis, Lindelof Lemma, Lindelof's Theorem, Lindelof Space, Fragment Lindelof Principle, Picard-Lindelof Theorem. Ernst Lindelof was a Finnish mathematician who worked on topology and partial differential equations. He also wrote on the history of Scandinavian mathematics. Lindelof's first work in 1890 was on the existence of solutions for differential equations. It is an outstanding paper. Then, he worked on analytic functions, applying results of Mittag-Leffler in a study of the asymptotic investigation of Taylor series. In particular, he was interested in the behavior of such functions in the neighborhood of singular points. He considered analog of Fourier series and applied them to gamma functions. He also wrote on conformal mappings. Later in his life, Lindelof gave up research to devote himself to teaching and writing his excellent textbooks. In addition to the 1905 work referred to above, which is largely on his own research, he wrote the textbook Differential and Integral Calculus and Their Application, which was published in 4 volumes between 1920 and 1946. Another fine textbook, Introduction to Function Theory, was published in 1936. Another important role which Lindelof played in Finland was the encouragement of the study of the history of mathematics in that country. For his outstanding contribution to Scandinavian mathematics, he was honored by the universities of Uppsala, Oslo, Stockholm, and Helsinki. Lindelof Hypothesis. The Lindelof Hypothesis is a conjecture by Ernst Leonard Lindelof about the rate of growth of the Riemann zeta function on the critical line. This hypothesis is implied by the Riemann hypothesis. It says that as t tends to infinity, since epsilon can be replaced by a smaller value, we can also write the conjecture as for any positive epsilon, Lindelof's lemma. Let the real line have its standard topology. Then, every open subset of the real line is a countable union of open intervals. Lindelof's theorem. It states that a holomorphic function on a half strip in the complex plane that is bounded on the boundary of the strip and does not grow too fast in the unbounded direction of the strip must remain bounded on the whole strip. Lindelof's space. In mathematics, a Lindelof space is a topological space in which every open cover has a countable subcover.